It's a big pleasure to stand here on stage and talk to you about our latest work. We identified that there are a lot of user flows that require to send a token through different networks and through different protocols. And that's something that I refer to as a token journey here in this talk. Token flow, token journey. And some of the steps along this token flow or token journey could be to send a token through a bridge from one network to a different network, or to send a token through a DEX in order to exchange it into a different kind of token, or even to off-ramp a token into the fiat world. And when you look at such a token flow, a token journey, it could even be that you need to combine all of these different steps and all of different kind of manners. Now, something that's very crucial for these kind of token flows is that you want to do it with the best user experience possible. That means that you want to automate this as much as possible. You don't want that the user needs to execute these steps manually, because that would first require that the user needs to hold fiat currency or native currencies and all the networks involved, or would even require that the user needs to have a wallet for all these networks, because these networks can be quite different and you might need different wallets. We have been looking at a system, or we've been working on a system to solve this problem and to actually automate all kind of different token flows. Now with this, I want to introduce myself. I'm Torsten, I'm the CTO of Pendulum. And you might know about Pendulum. Pendulum has been a parachain on Polkadot for already more than a year. Pendulum primarily deals with connecting fiat to DeFi. And we work with fiat tokens, we work with doing forex on blockchain, and also on-ramps and off-ramps directly from fiat to DeFi, and then all kind of DeFi applications that you can think of with fiat tokens. Now we have been over the time since we started, we have been working on some powerful primitives, and now we finally can connect them in order to achieve complex token flows. And this new system I have been mentioning is called Vortex. So today is actually the first time that we announced Vortex publicly. Vortex is still in the prototype phase, I need to say so much, but the goal of Vortex is to achieve all different kinds of token flows. And we want to primarily look at token flows that link crypto payments to off-chain spending. And we also primarily want to look at token flows that involve forex optimized DEXs. So when I say connecting crypto payments to off-chain spending, this falls directly into our DNA at Pendulum, namely that we connect fiat to DeFi. Something that's important to know about Vortex is that it's not just constrained to Pendulum or even to Polkadot, but Vortex is truly multi-chain, it's very flexible, and it's also EVM compatible, as I will show today. And I want to stress again that the goal of Vortex is to achieve one-step user experiences that are completely automated. Now, all of this is quite abstract, so let me start to look at a very concrete example. Let's look at a concrete token flow with Vortex. And the very important use case I want to look at is a use case of a freelancer in an emerging market receiving their salary in US dollar stablecoins. In this case, USDC. Could also be USDT, doesn't matter. I said emerging market. Let's look at a freelancer in LATAM, or more precisely Brazil. That means that also from time to time, they will need to off-ramp their US dollar stablecoin into their local fiat currency in order to make actual purchases in their country. And the fiat currency in Brazil is, of course, Brazilian reais. Today, we'll also look at a use case where we are a European freelancer who receives euros because it relates a little bit more to us here in Europe, but doesn't matter. The flow is exactly the same. Now, the flow that we implement here in this example actually looks quite complex at the beginning. But first, it's actually a testament of the power of Vortex to actually really automate complex flows even. Let's look at the example. In this flow, we first send tokens, the USDC tokens from Polygon via the Axelar bridge to Moonbeam. Moonbeam is an EVM-compatible parachain, so now we're already in the Polkadot ecosystem. We can then employ XCM in order to send those tokens directly to Pendulum. Now, Pendulum has a very crucial component, namely that's where a forex-optimized AMM comes into play. And this is where we exchange the USDC into a token that represents the end currency. In our example, a Euro token, which in here is called EuroC, or for the Brazilian freelancer would be Brazilian Real token. Finally, we use our Spacewalk bridge, which is a bridge that we built between Pendulum and Stellar in order to send those tokens over to Stellar. Now we're on yet a different network. And on Stellar, we then have a native off-ramp for either one of those fiat currencies to directly off-ramp this into the user's bank account. This flow looks quite different, quite complex, and you might ask, why not do it simpler with conventional methods? But this flow actually is very powerful because it uses the powerful components that we use, and are called the holy trinity of this flow. And these three components together actually achieve that you can save a lot of fees, actually up to 85% compared to conventional methods that you could use nowadays. Let's start with the last component. The last component is a direct off-ramp in Stellar. Stellar is very powerful for our use case. Stellar has a lot of natively issued fiat coins, more than on any other blockchain. And those natively issued fiat coins also allow to have direct compliance on and off-ramps on Stellar. And we want to use that. We want to employ that for our use case. And for that reason, we built Spacewalk, which connects those on-ramps and off-ramps then actually to Pendulum and actually all of Polkadot. We just recently passed a treasury proposal to support Spacewalk. And the main goal of the treasury proposal is actually to have those on-ramps and off-ramps available for all of Polkadot, something that you didn't have before. Now, the third component in this trinity that's very powerful is this forex-optimized AMM, because it gives you the best slippage and the best fee in order to exchange your fiat currencies. And as you can see on this flow that there's no single SEX involved. Everything is completely decentralized here. And I think that's a very cool system. Now, let me show you this example in real life. I actually have a live demo. So let's see whether this works. I said it's a prototype, so it looks very prototypical, but it's a proof of concept that the whole flow works. I said that we start with Polygon, so I now actually use my Polygon wallet or some kind of EVM-compatible wallet, and I start with USDC on Polygon, and I want to off-ramp into my European bank account. Let's say I use 12 USDC. Here you see that it actually already uses our AMM that's in the middle of the whole process in order to compute the exchange rate. This is a very favorable exchange rate. Not exactly in this example, but this example is a prototype. But anyway, this will be a very favorable exchange rate, something that you will not find in this sense with this low slippage somewhere else. And now we can actually kick it off. I said everything is totally automated. And let's see whether this really works in an automated manner. I click on Prepare Prototype. And now, of course, this happens in a very compliant manner. That means I would also need to use KYC. And I do this with the off-ramping partner. That's something I don't want to do here in this demo. So I actually prepared this already. I did the KYC. And I would now need to enter my bank account and so on. It's private information. Obviously, I don't want to share this here. So I prepared this. I can now just directly click on the button and go and continue the flow that I would do if I did the KYC. So now the flow actually starts. There's a little bit more cryptic information. I now use my Polygon wallet in order to sign the transactions. In this stage of the prototype, I need to sign 2 transactions, but we will optimize it so that it's really at the end a single click, a single transaction that you need to execute. And now the flow starts. The flow will involve a couple of transactions, a couple of bridges, as you saw. So it will take a few seconds, minutes, a few minutes in order to complete. But I called this talk token flows without any hand-holding. That means that we don't need to stay here. Everything will happen in the background. We don't need to do anything. So I can go back to my presentation, and then in a few slides, we can actually look whether everything worked. During that time, let's continue with the presentation. And let's actually ask the question, what is so complicated about automated token flows? It sounds like this is a solved problem, and in many ways it is, but not in all cases. And if you want to do it in a flexible manner, then you need to look at certain problems. The main problem is that when you want to make it in an automated way, you don't want to require the user to have a wallet for every of the subsequent chains that are involved in flow. They only need to have a wallet for the very first chain. In our example now for Polygon. Of course, there I need to have a wallet because that's where I hold my tokens. But where do the tokens arrive once they arrive on the subsequent chains? If they arrive on an account, then if you want to do it in a compliant manner, and of course you want to do it in a compliant manner, then you need to have a custodian to actually take care of the funds, of the user funds. And having a custodian comes with all of its own problems, so we don't want that. Of course, we don't want that. We want to avoid this. Another way would be to involve smart contracts. There you can also do it completely decentralized in a way that doesn't involve custodians, but that's something that doesn't work on every single chain. For example, we had Stellar, and on Stellar you cannot do this. Although Stellar now has smart contracts, you cannot do the on-ramp and off-ramps with smart contracts. You need to do it in a more conventional way. And with our system, we can actually do it in a more flexible manner than through smart contracts or runtime logic. So now let me go to the basic idea that underlies our system. And I do this in a very simplified way here. So the basic idea is to introduce ephemeral accounts. That means that at the beginning of the flow, we create ephemeral key pairs for the user for every blockchain that is involved that requires some kind of ephemeral account. In the token flow I just showed, that would be the case for Pendulum and for Stellar. Something that's important is that this ephemeral account, or the secret of that account, always stays in the user interface of the user. We never touch that one, and we are not allowed to touch it due to compliance. So it stays on the user side, and the only thing we do is to fund those ephemeral accounts, or not we, our system, Vortex, funds those ephemeral accounts, and then the system identifies every single transaction that needs to be executed along the flow. For each of those transactions, we create those transactions, and then we ask the user interface of the user to sign those transactions. Once we collect all the signatures, or once Vortex collects all the signatures, we can then kick off the flow. So that's important. We only start the flow once we have all signatures. It's important for security because you don't want to already send the tokens into some ephemeral accounts and then risk that there's any loss of those tokens because you don't have all signatures yet. So we collect them, then we wait. Once we have them, we can actually start the process. The user is not needed anymore. User can need. The automated flow now happens completely by itself without any further ado. Our system will then submit transaction by transaction whenever it's required. And once all transactions are sent, then we can clean up the ephemeral accounts and send back all the tokens that were not used. Maybe we can have a quick look at how our flow is doing. It's still at the Axelar phase here at this point. Okay. Sorry? I don't know. That's not necessarily expected. I would still be at this phase. Let's see. I used it a lot of times. It never happened, but I'm confident that we will still get there. So while this is happening in the background, let's actually look at some parts more closely of this flow, because it's quite interesting what's actually happening there. What I will do is I will actually start at the end of the flow, namely at the off-ramp, because that's something that we already touched when we used the example, when we used the demo. You're already familiar with this. So let me stress again what's very powerful about Stellar. Stellar has a network of fiat gateways. These are native on-ramps and off-ramps for many different kind of fiat currencies that we employ for Vortex. All these on-ramps and off-ramps are done in a compliant way and in a standardized way. So there are standards on Stellar that allows us to use all these on-ramps and off-ramps in the same fashion. And those on-ramp and off-ramp providers also take care of KYC. So that also is something that comes with the whole system. It's very neat. Now let me go in order of the flow. You saw that after we leave Polygon, we arrive on Moonbeam. And when the funds arrive on Moonbeam, they will actually arrive in a smart contract of Axelar. And we instruct that smart contract to directly send those tokens over to our smart contract. That's the smart contracts of Vortex. And that smart contract will just further send those tokens to the X tokens precompiled smart contract. That's a smart contract on Moonbeam that allows to use XCM. That means that with the smart contract, we can then directly further forward those tokens over to Pendulum. And all of this happens already in a completely automated fashion. Yeah, because it just involves smart contracts, and that means we actually don't need any ephemeral account on Moonbeam. It's also quite nice. Now, once the tokens arrive on Pendulum, I already said that that's the point where we use our Forex optimized AMM in order to exchange the USDC into EuroC tokens. And once that happens, we will then further send tokens over to Stellar with our Spacewalk bridge. I already gave a couple of presentations about Spacewalk, so I don't want to talk too much about Spacewalk here, but just some basics about what's very special about Spacewalk. The first one that's very important and useful for us is that Spacewalk actually allows to transfer all kinds of Stellar assets. I already said that Stellar has all those fiat tokens, and we can send all those tokens with the Spacewalk bridge. It's something that you will hardly find with any other Stellar bridge. Most Stellar bridges just allow to send the native currency. Spacewalk is also completely decentralized, and I tried to show it there that one of the components inside Spacewalk is a system of vaults, and that's a censorship-resistant network of vaults. Everyone can deploy their own vault. Everyone is free to contribute to Stellar, and for that reason, it's decentralized and also trust minimized. But something that's also important is this other component, namely the Stellar Oracle. That's actually the blockchain relay that relays information from Stellar over to Pendulum. And it's called Oracle, but it's completely decentralized as well. And it's provably as secure as the Stellar consensus protocol itself. So it really taps into the protocol that underlies Stellar and can really provide maximum security here in this case. So now, finally, I want to talk a little bit more about this Forex AMM that I already mentioned, but maybe we can have a look at the token flow, and we see it actually got stuck at Axlar. That's a shame. Let me just try to do it again, so maybe we can have a little bit more success this time. Again, it's a prototype. Of course, all of this will be resolved. We take all kinds of favorable assumptions for this prototype. That will not always hold, for example, when there are too many gas fees. So hopefully this is not a problem this time. Need to sign them again. And there will be the other signature required now. In a few seconds, and I can go back to the presentation. Sorry? What about it? Okay, there should be actually another signature now that's required. Anyway, let's go back to the presentation. So let's talk about the Forex AMM. This Forex AMM is powered by Nabla, and Nabla is a technology that is a very advanced version of an automated market maker. It's quite different to your conventional market maker that you would find, for example, with Uniswap. And I don't have a lot of time to go into the details of Nabla. This is also very interesting itself, and it would require a complete presentation by itself. So just some very basic principles. Maybe I can summarize Nabla as being an automated market maker that reduces and lowers the risk for the liquidity provider, and it also reduces the risk for the person that wants to do a swap. The first one by reducing any kind of permanent loss, and the second one by reducing slippage. And two principles that underlie Nabla is that first it uses single-sided liquidity. This is something that is called swap pools. So instead of having your typical pool pairs that you find in something like Uniswap, you have swap pools, and you have a swap pool for every currency involved in Nabla. And when you want to provide liquidity, you don't provide liquidity for a pair of currencies, but you provide liquidity only for swap pool by swap pool. And by that, you can completely separate your asset provision from your risk taking, because you can directly choose what asset you want to provide your liquidity for. And this then provides a more efficient use of capital. Another very important aspect of Nabla is that it is a proactive market maker. That means that the price between assets is not determined by arbitrage, as you would find on a conventional market maker, but you will actually employ a price feed. So you have a price feed oracle, and you use that price feed in order to determine the current price between assets. And this first reduces arbitrage, which makes it much better for liquidity providers because it reduces their risk, but it also greatly reduces impermanent loss. I cannot go into any detail of impermanent loss, but when you're familiar with automatic market makers, then you know that for liquidity providers, that's one major source of any risk. And also the slippage is very low because it works quite differently. Just quickly about the swap pools. Here's an example where we have a Nabla instance with 4 different swap pools for 4 different fiat currencies, USDC, USDT, EURC, and BRL, and those swap pools are completely isolated, and you can now swap between every different pair of swap pools. You don't need to just look at token pairs, but every single pair of swap pools is possible to do a swap with. And you can also have an arbitrary number of those swap pools. So you can connect a lot of different fiat currencies into a simple Nabla instance. Whenever you do liquidity provision and whenever you want to withdraw liquidity again, you also do it swap pool by swap pool, as I already said. And again, I want to stress that the price of tokens is not determined by the ratio of the pool balances, as you would find on the conventional AMM, but is completely determined by the oracle and some small amount due to slippage. Now finally, let me talk about the bigger picture of Nabla. Nabla is developed in Solidity, so it's not primarily for Pendulum or for Polkadot, but it's obviously a system that will be deployed on EVM chains. This is in work. The first mainnet deployment is actually on Pendulum, and that's the mainnet deployment that's involved in this Vortex prototype. Unfortunately, I could not demo that today because we didn't get above this first step. But anyway, we are also having a testnet campaign currently on Pendulum on our testnet. Everyone is free to join the testnet campaign and to test Nabla, whether it works properly. You can, of course, get some tokens for that in exchange. I'm very happy if you have a look at this. And with these words, I want to close my presentation and want to give some links here about Pendulum and ask you to get involved or to give some feedback. Very happy to talk to you. We also have a booth today over in the big hall. You can just come over and then you can see the demo again. This time it hopefully works and there's not a problem with fees on Axelar. I blame it on Axelar and gas fees on Polygon. This is actually not really one of the components that we built. I'm pretty confident the components that we built would have worked. But anyway, really happy to meet you over there. And if there are any questions, then please ask now. We still have 2 minutes left. And with this, I also want to share my link here. Thank you. There's a question.
Thank you for the presentation. You said that during off-ramp of crypto, you gather all of the signatures before you actually continue with the off-ramping process. How do you guarantee that when the time comes to execute the transaction, that the funds are still in the wallet and they haven't moved yet?
Because we have complete control about what transactions will actually happen. Once the first transaction is kicked off, of course, if the user doesn't sign the first transaction and it's never submitted, then of course the subsequent steps will never happen. That's exactly what happened in the demo now. So the transactions will be signed, but they will never be used. So there's no problem. But once the first step happened, once the user signed that first transaction, then everything after that happened automatically. And we have complete control about monitoring where everything is right now, where are the funds, what's the next transaction to happen. When there's a bridge involved, of course, then we need to wait until the bridge is done. Mm-hmm. That's something where we might not have control if it's not our bridge, like in the case of Axelar. But then we monitor constantly what the next step is and when it can be actually executed.
Thank you.
There is one maybe more interesting example. That's because we have the swap in there, and for the swap, it could be that in the meantime the exchange rate is different because we use this external price feed, and that's something that we cannot that we cannot 100% guarantee to you that the exchange rate will be exactly the same once the transaction will happen. But there we have a system of reducing the risk by hedging. It's not a prototype, but it will come that whatever happens, you will be guaranteed that you have the exchange rate that you see at the beginning if this happens in a certain time frame, let's say within 10 minutes or so. It's not just the slippage, there are different risks. One is the slippage because there could be other transactions that happen in the meantime, but another risk is that just the price could change in the global forex market.
Thank you so much,
Thank you.
Torsten.